Assalamu alaikum everyone. I hope you guys are doing great. So in this lecture, we are going to talk about the third unit of trigonometry, that is the addition formula. So let's get started. It's 3.3 addition formula. Okay. Now, so far we have been talking about the P3 maths, that's basically the A2 maths, and we were discussing trigonometry. We are done with the first two units, and today we are going to talk about the third unit. Now, I'll talk about a few things in detail. We'll talk about a few formulas that you guys would have to keep in your mind at times. In the data booklet, such things are given, and then you guys would be in a better position to understand everything well. Okay. All right. So let's get started. We know that sine 30 plus 60, I can write it as sine 90 is basically equal to 1. Why is it 1? You can use your calculator or you can use this understanding to get the idea that if I make the graph of sine, it is going to be something of this type, and this is 90, and at 90 it is 1. Okay, but if I say that sine 30 plus 60 is basically sine 30 plus sine 60, then this would give me sine 30 is 1 by 2 and sine 60 is root 3 by 2. So this certainly is not equal to 1. This means that sine 30 plus 60 is not equal to sine 30 plus sine 60. Then what exactly is it equal to? This is what we are going to discuss in this class. Okay, so we have some formulas which we need to take in account in order to understand all of these questions. So let me just write them down. We have 6 in total, but I will write down 3 so you guys would be able to understand them. Okay, so sine A plus B is equal to sine A cos B plus cos A sine B. So if you would be having sine A plus B, you can write it as sine A cos B plus cos A sine B. And if you would be having sine A minus B, in that case, it would be sine A cos B minus cos A sine B, right? So this is the first two equations that we use. Think about them as identities because we will be using them in order to solve questions, prove identities, solve equations and stuff like that. Okay, the next one is cos A plus B. Cos A plus B is cos A cos B minus sine A sine B. So cos A plus B is cos A cos B minus sine A sine B, and cos A minus B is cos A cos B plus sine A sine B. So important part is in sine, Whenever we have positive, we would be having positive here as well. And if we have negative, we would be having negative here as well. And in cos, it's other way around. If you have positive, you would be having negative, and if you have negative, you would be having positive in the formula. So this is the difference. And the last one is for tan, it is tan A plus B is equal to tan A plus tan B divided by 1 minus tan A tan B. So tan A plus B is equal to tan A plus tan B and 1 minus tan A tan B. Similarly, if we have tan A minus B, you would be having a minus here, and here we would be having a plus, okay? So this is basically the difference in this thing. Okay. All right. So for minus, we have minus in numerator, and for minus, we have plus in denominator, and for plus, we have plus in numerator and minus for denominator. So this is something that you guys would have to remember. And once you have all of this in your mind, questions would become very, very easy for you. So now if someone says what is sine 30 plus 60, you guys would be knowing that for this, you need to use this formula and not write down sine 30 plus sine 60. That's certainly not the case, okay? All right, so let's talk about a few questions and then things would get better. Example number 1. By considering sine 45 plus 30, prove that sine 75 is 1 plus root 3 to root 2. Okay. All right. Let's talk about the solution of this one. So you need to prove sine 75, and for that we need to consider this, okay? So I can write it this way. Sine 75 is basically equal to sine 45 plus 30. And for that, I need to refer to these addition formulas, that sine A plus B is sine A cos B plus cos A sine B. So this would be sine 45, my A is 45, cos 30 plus cos 45 sine 30. Next, I need to plug in the values of sine 45. It's 1 by root 2. Cos 30 is root 3 by 2. Then cos 45 is 1 by root 2 and sine 30 is 1 by 2. The denominators are same, so I can write it as sine 75 is equal to 1 plus root 3 by 2 root 2. This is going to be the answer. Okay. Okay, let's talk about example number 2. Here the question is, prove that 2 cos theta minus pi by 3 is identical to cos theta plus root 3 sine theta. This is the identity sign, and we need to prove that the left hand side is identical to the right hand side. Okay, so for this you can start off with any of the two sides and then make it look like the left one or the right one. This is the left hand side and this one is the right hand side. So let's talk about the solution. Left hand side, that is basically 2 cos theta minus pi by 3 is basically equal to 2 outside, and I'm using the cos addition formula, so it would be cos theta into cos pi by 3 plus sine theta into sine pi by 3, and this is going to give me 2 into cos theta. Cos pi by 3 would basically give me 1 by 2 plus sine theta. Sine pi by 3 would give me root 3 by 2, and I can write this thing as this 2 and this 2 would be cancelled, and then this 2 and this 2 would be cancelled. So I would get cos theta plus root 3 sine theta. That is basically my right hand side, hence proved. Okay, so we started off with the left hand side. We took the left hand side, we applied the addition formula, and we simplified, and this thing was equal to my right hand side. So this is how we prove it for such cases. Okay. All right. So I hope that by now you guys were able to understand some of the some part of this chapter, and with this example you would get a better understanding. Okay. All right. So let's talk about a past paper question. Okay, here the question says, solve the equation cos theta plus 60 equals to sine theta minus 45 for theta that is between 0 and 360 degrees. Okay, So this is my equation, and we know how to solve trigonometric equations. We need to first convert the two trigonometric functions to one trigonometric function and simplify, make theta the subject, and find all the values which are lying within this interval. So let's get started. All right, so let's talk about the solution of this one. The left side would basically be cos theta into cos 60 minus sine theta into sine 60, that is equal to 2 sine theta cos 45 minus cos theta sine 45. This would become 1 by 2 cos theta minus root 3 by 2 sine theta, and this thing is equal to 2 multiplied by sine theta, and cos 45 is basically going to be 1 by root 2. Sine theta would come as it is, minus 1 by root 2. Cos theta would come as it is. And now we need to just take sine on one side and cos on one side. And after simplifying, I am going to get root 2 plus 4 divided by 2 root 2 equals 4 plus root 3 root 2 divided by 2 root 2 sine 30. And this is going to give me root 2 plus 4 divided by 4 plus root 3 root 2. Here I have missed cos of theta, and I'll take cos of theta on the other side, so it would become sine theta divided by cos theta, and we know that sine by cos is basically tan theta, and this is what I wanted. Initially I had two different trigonometric functions in the question. I had cos and I had sine, but after simplifying, I got tan only. And finally, I can write it as tan of theta is equal to this thing is basically 0.8394. Now we need to find the value of theta. So let's get started. Let's make the quadrants for this. First quadrant, second quadrant, third quadrant, fourth quadrant. Tan is positive, so it's positive in the first one. All are positive. Add sugar to cup, and it's positive in the third quadrant as well. Let's find the basic angle. So theta would be tan inverse 0.8394. It would be 40 degrees approximately. So this is going to be 40 degrees. Similarly, the basic angle would be same in the fourth quadrant as well, and in the third quadrant as well. And the angle is going to be all the way from here to here, and it would be theta equals 180 plus 40, that is 220 degrees. So this is going to be the answer. So we know that for the final values, we need to make sure that we look at the quadrants, and we need to make sure that all the angles which we are finding must lie in the required quadrants, because that is mandatory. All right, okay. So let me go through the entire concept again, and in case of any questions, you can ask me directly. Okay. So for example number 1, you had to prove That sine 75 is 1 plus root 3 divided by 2 root 2. For that, the reference was given. We had to use this as reference. So we just use sine 75 equals this thing. And then we just use the addition formula. This would give me sine 45 cos 30 plus cos 45 sine 30. And we just added values. And finally, I got this one. Okay. All right. Then once we were done with this, the second example was basically about proving this identity. So we again have a lot of choices where it is about the identities. You can use the left side, make it look like the right side. You can use the right side, make it look like the left side, and so on. We have multiple ways. So 2 cos theta minus pi by 3 was the left side. We started using that. We just used the addition formula. And after expanding and everything, we made it look like the right side was solved. Then at the end, we discussed the past paper question where you had to solve an equation that was basically a trigonometric equation. But for that, we had to use the identity. So on both the sides, here we had plus, here we had minus. Step one was to expand both the sides and then simplify. And after that, we got this. Here we have sine. Here I have cos. I cannot cancel them. I can use sine and cos to get third trigonometric function. So I just did sine divided by cos. And this gave me tan. So this is tan. And here I had this expression. The mathematical value of this expression would be this one. Now I know that tan theta is positive. So first of all, I need to think in which quadrants exactly is tan theta positive. So it would be add sugar to cups. It was the first quadrant where we have all positive, and it was the third quadrant where we have tan positive. We know how to find angle in the first quadrant. It's this angle directly. That was the basic angle. And for the third one, it was the red angle. So that would basically be calculated by doing 180 plus 40, and this gave me 220. So since 40 and 220, both of these angles were lying in this range, that is why this was correct. If let's say, if the range was only between 0 and 180 degrees, we would have said this is not included in the range because our interval is just still 180 degrees. So for these questions, we need to think about a variety of ideas. We need to be careful about a lot of things. And then you guys would certainly be in the position to get correct answers. All right, okay. So that is it. In the next class, we will be talking about double angle identities. And then, we will be using basically the same formulas to find those, but still the idea is going to be a new one. Okay. So that is it. In this class, we have discussed these questions. And here are some, notes for whatever we have discussed in this chapter. In case if you guys are interested in these notes and the recordings, you can use the link in description to buy the course or one lecture. And if you guys are interested in proper live classes, again, you can use the link in description to get yourselves enrolled for our live classes, where we cover the entire syllabus with a lot of past paper questions. So that is it. I hope you guys were able to understand everything. If you have anything, any question, just comment down below. I'll try answering you, or you can just register yourselves for our live classes. So that is it. Take care, all of you. Have a good day, and Allah Hafiz.